All right, sixth graders, we are continuing our flipped classroom series. Today you get a new packet. I'm actually filming this before school, so I should say you will get a new packet today. But it's on finding the area of composite figures. So we have been working the last couple days on finding the perimeter of composite figures, distance around. Now we're finding the area of composite figures. If you will remember, when we talked about finding the area of a parallelogram, the formula we used was to take the base and multiply it by the height. Okay. Then when we added to that, we went to a triangle. And we said that a triangle, you take base times height, and then you divide by 2. And we said that because we said if you have a parallelogram is nothing more than 2 triangles if you divide it in half. So accordingly, we divide it by 2, right? Then we went on to a trapezoid, and when we do the trapezoid, is you take the height times base number 1 plus base number 2, and then when you get all done, you divide it by 2, okay? And the area of a circle was to take pi times the radius squared. Remember, in a circle, the radius is halfway across. So we have been finding the circumference or the diameter, but now we are dealing with the radius. Okay, pi times radius squared is the area of a circle, and then of course, if it is a semicircle, that is pi times radius squared, and then we would divide by 2 at the end. Okay? So all of these things are area formulas that we are going to have to remember for today. Okay? So parallelogram, I'll just put P. Base times height. Parallelograms include squares, rectangles, any four-sided figures, four-sided enclosed figures with straight lines. Okay? Triangle, base times height divided by 2. Trapezoid, you take your height times base number 1, base number 2. Again, make sure the height, like we've talked about in class, make sure the height goes straight up. So in a trapezoid, they may label this side like 3, but the dotted line is different. So make sure that when you're using height, we go like that. We're talking about like when you go to the doctor and they measure your height, you don't like stand like this, right? You stand straight up and tall. So just make sure that you remember that when you go for area. So today we have a bunch of figures in your packet that are comprised of multiple shapes. So if you look at the first page, page 561 in your packet, and you look at example number 1, you have a shape. Let's see. So in example number 1, you have a shape, and it looks something like this anyway. Okay, maybe like a castle, I don't know. Okay, so but it tells you that from here to here is 4 inches, and it tells you that from here to here is 6 inches. Okay, and then it tells you this one straight up and down is 6 inches, and it tells you this one on the bottom is 10 inches. Now, just like yesterday, we should be able to see that when you go here, since this is 6, since this whole thing is 10, right, and this much is 6, we should be able to see that from here to here, if that is 10, then from here to here, that whole thing would also be 10. So 10 minus 6 means that this little part here has to be 4 inches, because 4 plus 6 is the same as 10. Okay, so you will need to find that missing side, just like we had to do yesterday. Okay, but then they take the area of a triangle and they say, okay, and remember, we're trying to find area, so how much is on the inside? And area is nothing more. If this is inches, it's how many 1 inch by 1 inch blocks can fit inside this. That's really what area is. Okay, how much can fit inside? All right. So first, I have a parallelogram, which is a rectangle. So for my parallelogram, I take base times height, or some of you may say length times width as well. But I have 10 inches times 6, and I get a total of 60 inches. And then remember, we square it because it's 1 by 1, 1 by 1, 1 by 1. In other words, there's 60 blocks that are 1 inch by 1 inch that can fit inside the rectangle portion. Okay? Now I still have this up here that I have to do, but inside the rectangle, I should have 60 inches squared for my answer. Okay? Now I'm ready to look at my triangle. So I have to go back to my formulas that I remembered. And for a triangle, I take base times height, and since a triangle is half of a rectangle, then you should take and divide it by 2, right? So I take 4, which is my base, times 4, which is my height, and it is my height, because notice this line is straight up and down. I think in our homework earlier they drew them on the inside, but it's straight up and down here on the outside. So 4 times 4 is 16, but then it's a triangle, so 16 divided by 2 equals 8. Same thing, inches squared. And so they mean that inside here there's 8 inches squared, 8 1 inch by 1 inch blocks that can fit inside there. Okay? So when I erase this, if I'm finding the area of the whole figure, right, because it's a figure made up of 2 different things, my last step is just to combine the 2. So I would take 60 inches squared, and I would add 8 inches squared to it, and I would get a total of 68 inches squared, and that would be my final answer for that composite figure, whether you want to call it a rectangle, or not a rectangle, a castle, or whatever imaginative figure you want to say. Okay. So if you look at the check your progress right underneath there, there is a check your progress A, and on check your progress A, I personally, there's probably a couple ways you could do it. I personally would probably divide it into a triangle on the top and a rectangle on the bottom. It's possible to divide it into a rectangle on the bottom, but then to go straight down and make it kind of like a trapezoid that's tipped on its side. as well. Okay, but I would suggest doing a triangle. Okay, so if you do the triangle, you're going to have to find that missing side because the base says it's 12, and then on top it's 8. So there's a missing side there that you're going to have to find, and so that missing side should be 4. Right? I'll erase it. I'll show you. So A, it has like this, and like this, and like that, and like that, and something like that. Okay? So I personally, like I said, I would divide it here and make it a triangle and a rectangle on the bottom. I know I see a little bit of a glare. Let me see if it helps to push this down a little bit. I guess not. Okay, so with this triangle, this side is 10 feet. From here to here is 8 feet. And from here is 12 feet. And here is 4 feet. Okay? So if you take 12 and subtract 8, this has to be 4 feet. Because 4 plus 8 is the same as 12. So if here to here is 12, that means here to here also has to be 12. 4 plus 8 is 12. Okay? You also have to say, okay, if this is 10 feet, and this over here is 4 feet, then I didn't do a good job of drawing it to proportion. But if this is 4 feet, then this up here has to be 6 feet for the same reason. 4 plus 6 has to be the same as 10. Right? If this is 4, then that means this is 4 as well. And it tells you that the whole thing is 10. Okay? So 4 plus 6 is 10. Okay? So again, I personally would find the area of this little triangle, and I would find the area of this second. It's possible, I'm sure, to not do it that way, and to divide it down this way, and to take this trapezoid and that smaller rectangle as well. Okay? But I'll tell you that the answer for A should be 60 feet squared. The answer for A should be 60 feet squared. For part B, check your progress B, that's a composite figure. Remember to use radius, because it's a semicircle, use radius. The dotted line they have there would be the diameter, so you only need half whatever that diameter is on your worksheet. So make sure that's a semicircle. And your total for B should be 31 4/10 centimeters squared. Okay, 31 4/10 centimeters squared. All right, and I think that should do it for what I'm going to ask you to do for an assignment. So we'll stop right there. All right, enjoy.